What's more interesting is actually the push model. So that dashboard you have seen, the Bing Maps, it's based on Bing Maps, is a client application running here on my laptop using a service bus endpoint to receive data. So my StreamInsight Azure instance pushes the results into that service bus endpoint. My client receives it right there and is able to display it right away. So it's a true push model, which is a very desirable way to get really event-driven results. And that's the whole pipeline from the beginning to the end, showing to run these expressions within the StreamInsight Azure deployment and then consume the results. Let me go through 2 or 3 customer scenarios here that show what other people are doing currently with StreamInsight in Azure. Some of those are actually going into production already, and we are supporting them in a kind of private production environment. First of all is a security software provider. For most of these customers, I can't, since this is all preliminary, can't really talk about the customer itself, but I can still talk about the scenario. So in this case, what this company is doing is processing telemetry events from antivirus and anti-malware clients. And there's a telemetry front end that receives these events, and from there they go as telemetry data items, events into a StreamInsight Azure deployment, also stored in Azure table on the side. And StreamInsight is aggregating the data. What it's doing is it is looking for certain patterns in that incoming stream of detection events from those clients, right? So whenever a signature is detected, there is an event, and if there is a high number of signatures detected, I might have an outbreak of a certain malware or virus. And being able to detect that as fast as possible is, of course, very, very high value. And using an event-driven framework like StreamInsight really helps doing that with very low latency. So those pattern matchings and aggregations are constantly executed against the incoming data, and representing aggregations that then go into a SQL Azure database in that case. At the same time, there is a web service through an alerting mechanism to a response team so that I can react on these things, potential outbreaks, as fast as possible. And the response team also has the ability to take the persisted data and use queries to data mine the data and refine the queries, which then potentially get looped back into the real-time deployment to refine and modify the queries based on further knowledge derived from the persisted data. So that's a typical cycle where you have some real-time detections, computations, results being stored, users analyzing the results and figuring out how to refine the computations, and then going back and submitting them into the real-time system. There was a question about the demo in the slide deck, and we can take that offline and see how we can provide that best. It's already been answered. Second customer, this is one I can mention, is Audience Insight, which is the name of the framework that I mentioned in the very beginning, that telemetry processing of video distribution, the keynote chart that you have seen. They have done that not only for the keynote, but for many other video distribution scenarios. MSN, Build Conferences, Channel 9 is using it. And like I've said before, the event source here is a Silverlight player, running an Internet Explorer, showing the video feed of the respective events, and at the same time sending back telemetry events about the video delivery, about the user experience, and those go into a StreamInsight deployment in Azure through that REST API, the REST interface, where I have also the possibility to spool that data into Azure storage, the raw incoming data, and do the transformations like the geo-resolution, debadging the video client batches, telemetry events into single HTTP packets. So I need to debadge them, and I can do that simply through that expression that I define over the incoming raw data. And from there, I go into my queries, like the buffering or the session duration, what you've seen before, the aggregations over time, the number of errors, for instance, and grouping that by location to see is there a certain area, certain geographical area where I have more errors that could point me to a problem with my video distribution network that has a routing problem or something like that. Again, doing all of that in real time. And then persisting that in the database so that I can have a dashboard feeding off that database using, in this case, the OData interface to display and make that humanly consumable. So again, typical example of how to integrate Windows Azure StreamInsight into that end-to-end telemetry analytics use case. That's another customer that is currently using the service in its CTP phase. In this case, that customer, that scenario wants to process telemetry events from cell phone users to reason about their behavior and then feed back information to the user. They have their own service front end from where data is then collected and sent into the StreamInsight Azure deployment. And what they do from there is two things. They also do the raw data spooling, the storage, but also they have, in this case, I think more than 60,000 events per second. And using a database right there would just not be very feasible to persist all that noise, basically. Instead, they use StreamInsight to aggregate in real time in the cloud every 60 seconds for the last 1 hour and persist that in a SQL database from where I can now run reports against the pre-aggregated data and aggregate it even further, roll the data up even further. But what they're also doing, what's very interesting, is use the raw incoming data. They don't want to lose that information. Just to put it into a database right away, but use MapReduce frameworks to data mine that information and then derive further knowledge from that and put that into SQL as well. So there is, again, this whole cycle of finding out information, persist that, finding out more based on the historical data, have a kind of a data scientist workflow against the historic data, finding new queries, finding new models, and then putting that back into the real-time deployment. And that's a typical pattern that we see very often happening around event processing and event-driven deployments. All right. I'm almost done here. Let me talk about the roadmap. We mentioned here the June CTP. In the meantime, I have to admit I'm reusing a slide deck that's a few weeks old. In August, we have updated our CTP. We call it the August CTP, surprisingly, which added a few features like HTTPS on data ingress, for instance, which added the dependency on Azure SDK 1.7. That was a big ask from customers who wanted to be consistent with their other Azure development efforts and be able to use SDK 1.7. So we had a few updates there in August. We are looking at going into a public preview, even being available on the Azure portal and having some further features implemented by the end of the year. And I say that very tentatively, as you know, as we usually have to do it, because we can't commit to anything at this point, but that's our effort. And then later, next year, hopefully not too late next year, we want to be able to make the service generally available with a finalized business model, with a pricing model, and have a production-ready service with an SLA, providing StreamInsight in Azure. And related to that business model, a few more words about scale. I briefly mentioned that this is in effect a single tenancy service. So what is really one of the central design tenets and goals is to make performance predictable and dedicate compute resources to use cases. So if you have tens of thousands of connected clients, and you know you will need multiple cores and multiple VMs to process that data, you can be sure that nothing else is running on these machines except your code. So this helps us with providing a level of security and privacy and encapsulation, as well as predictable performance. So you get dedicated capacity and consistent, repeatable performance. In the current version of the CTP, we don't scale out the analytics node that runs the StreamInsight engine. We just scale it up from 1 to 8 cores, but we do scale out across multiple VMs the ingress stage where the stateless event per event transformations are running. So it is already providing a transparent scale out way of processing streaming data. And the model of dedicating machines and cores to customers really help make the service predictable and dedicate capacity. All right, I think it's probably my last slide. Resources. First of all, if you're interested in participating in CTP, it's private, but it's not restricted in any way. So just email me that alias at Microsoft.com or my colleague Tio. And there are a few StreamInsight resources. If we can make this deck available, you can just click on the links, search for StreamInsight. There is not that much information about Azure StreamInsight because it's not really a public service yet. We have blogs about it, but most of the public information is about the core StreamInsight. And with the cloud service, we are still in the CTP phase without that much public available outreach yet. That's all I have. Thank you very much. We are pretty much on time. We have, I think, 5 minutes left for questions. Let me know.